Okay, so given the information in the beginning of the video, which you should pause and copy down, same for these questions that I'm doing. You should probably, if you're learning it, pause the video before I come in and copy down the equations or the problems. So, given a population mean of 20, a population standard deviation of 15, and we take a sample of 81, okay? So this can be from any set of data. We're going to compute the mean of the sample, and then we're going to compute what is called the standard error of the mean. We have those equations, so it's not very hard to do. We know mean of the sample is just the mean of the population. So it's 20. This has a little equation that goes with it. It's the population standard deviation divided by the square root of the number of sampled. So we have 15 divided by the square root of 81, which is 15 divided by 9, or 5/3. And if you want a decimal out of that, you can get that. 1.667. So it's pretty easy to calculate there. These questions do get harder, and they will. Given a sampling distribution from a sample of 25, so here's our sampling distribution. This is not the actual population, this is just a sample, which can be extended to the population. So we're going to find the mean of the population. We don't know that, but it is right here because they're the same number. So that's just 40. And then if we were going to find the standard deviation of the actual population, then, well, we could take a look at this little chart here. We see the difference between here to here is 8. So that is our standard error. So we can go backwards from the formula. We know a few things. Here's our original formula. So if we're going to solve for sigma here, or the population standard deviation, all we have to do is multiply this over to this side. So we times by square root of n, and we get our new formula. Standard deviation equals the standard error times the square root of the number sample. So we'll use that here. We have 8 is our standard error times the square root of 25 for this case, which is 8 times 5, which is 40. There's no actual anything in common between these two numbers. They just happen to be both 40 for some reason today. Okay, so now we're going to build on the concept I just taught. So say we have a sample size of 30 from a population with a mean of 53 and a standard deviation of 12. So we're going to find a little bit more information about what's going on here. The mean is still going to be the same, 53. Standard deviation is 12, so we have this formula is 12 divided by the square root of 30, which is 2.191. So sometimes the homework wants 2 decimal places, sometimes it wants 4. We'll just go with 3. All right, so here's where the new questions start. Find the probability that the sample mean is less than 58.4. Okay, so we can write this like this, and that's how they're usually going to ask you. So I skipped the words in parts D and E. So first thing we want to do is, back from last section, we want to find a z-score for this. So remember that to calculate z, we take the sample minus the mean divided by the standard deviation. Well, now we're using our new numbers for this, okay? So we can put the little subscripts here if we want, but it means the same thing. So first we figure out what z is for this. That's 58.4 minus the mean of 53 divided by standard deviation. So we have 2.465. It's not our answer yet. We still need the probability that z is less than 2.465, which comes from our table. That I passed out in class, right? Standard normal table. And remember, when it's less than, we just take the number that we're getting from this, and when it's greater than, we do 1 minus. So that's what we're going to do here because it's greater than. But here we just take our answer. And you have to round this because this table only goes to 2 decimal places, so we're going to say 2.47. Okay, so we can go ahead and change that. 47. So we go to positive 2.4 and then over to 0.7. So that's right here, it's 0.993. We have to do the same here. So we find the z-score, 50.1 minus 53 divided by 2.191. So we get negative 1.324. Actually, we can round to 2 decimal places because the table only goes to 2, so we're going to say 0.32. But since it's greater than, to calculate this, we're going to do 1 minus the probability of z less than. Okay, so notice that's changing, all right? And we could say this number right here, negative 1.32. So that's 1 minus. Look at our table for negative 1.32. So negative 1.32 is right here, that's 0.093. And then we get our answer. Is 0.907 or 97 or 90.7%. Another way to say that. But make sure when you see greater than, you find your z-score for that number still, but you do 1 minus less than. If you know how to use the table right, you could skip that step, but it's better just to do it this way. So for here, we're bounded between two places, between 2 x's. So we have to find the z-score for both those x's. But we could say this is the probability of x less than 51. minus the probability of x less than 40. Okay, so we just have to find the z-scores for 51 and 40, which is not too hard. And then we'll just find these two numbers that come from it in the table. So we can call this 1 and this 2. So z for 1 is 51 minus our mean, 53, divided by 2.191. Z2 is 40 minus 53 divided by 2.191. So we get negative 0.91, only doing 2 decimal places because we're going back to a table anyways, and negative 5.93. Now this probability might as well be 0. Okay, so we're going to take that as 0 because it's so far to the left of the graph. We actually don't have to worry about it at all. Might as well be 0. Our table that only goes up to 3.9, which is almost 4 standard deviations, is already 0.0005. So we're probably going to throw that one out. So we have probability that z is less than negative 0.91 minus the probability that z is less than negative 5.93 equals negative 0.91 on our table is 0.181. And like I said, this one's so close to 0, we're just going to call it 0. And we have our answer. Okay. Suppose the length of pregnancies of a certain animal is normally distributed with a mean of 180 days and a standard deviation of 15. So we have a mean given from a population and a standard deviation of 15. What is the probability that a randomly selected pregnancy from a group of 16 is less than 172 days? All right, so all the work that we just did that was in pieces, we have to put that all together and do that all at the same time to get this answer. And then we can answer this. So we know our mean of the sample is the same, 180. But the standard deviation of the sample, or the standard error, is the standard deviation divided by the square root of n, number of samples, which is 16. So we have 15 divided by the square root of 16 is 4. And 15 divided by 4 is 3.75. So now we need to find now we need to find a z-score of this 172 days here, given this information. So we have, well, we want to know P x is less than 172, right? But we need really P of z less than, but we don't know what z is yet, so we're going to figure that out. So we have z equals x is 172 minus the mean of 180 divided by our standard error, which is 3.75. So we get negative 2.13. So we can fill that in here. Negative. And just go straight to the table and we'll find the answer. So negative 2.1 and then 0.03 is 0.017. Okay, and that's the answer. What is the probability that a randomly selected pregnancy from a group of 16 is less than 172 days? Well, it's about 1.7% or 0.017. Next question depends on this problem. If 100 independent random samples of n equals 16, so we did 16 people 100 times, were obtained, then how many samples would last less than 172 days? So it's the same problem, but really they just want us to take that number and convert it to a percentage because it's out of 100, okay? So really what we're doing is we're doing 100 times our 0.017, which is 1.7, but you can't have 1.7 people or 1.7 animals, so our answer for this is 2. Okay, here's our last example, and it's similar to a binomial problem, but we're going to make a frequency distribution and find the mean and standard deviation by hand. So playing a game where you roll 2 dice, and if the sum is greater than 8, you will win $10. If not, you'll lose 20. So I drew our table of values here. Red is good, green is bad. Green means lost. So we need to figure out, first of all, the probability of winning and the probability of losing, okay? So let's make a little table here. If we win, and we'll call each of these x, and then the probability of that x. If we win, counting up however many of these there are, and it's out of 36 because it's a 6 by 6 table, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so we can win 15 different ways out of 36. So 15 divided by 36 is, we're winning $10. And that's a 41.7% chance, or 0.417. If we lose $20, so we can say negative 20. And it's 1 minus this. Okay, so we can say 1 minus the answer we just got is 0.583. So there's our distribution. Very small, so it's not hard to deal with. Now, if we want to calculate the mean, remember the formula for the mean is mean equals the sum of all of our x values, well, for us it's just 1 to 2, of each x times its probability. And that looks a lot harder than it is, and we're going to calculate the standard deviation too for 2 values of x minus the mean squared times its probability under a square root. Okay. Like I said, it's a lot simpler than that. So all we really have to do to find the mean is multiply, each x with its probability and add them up. So we have 10 times 0.417 minus 20 times 0.583 equals negative 7.49. So it's an unfair game, basically. And then for this, all we do, this is really the important part. We're plugging in numbers into that. You don't have to look at everything else. We'll keep the square root around. So we have the square root of each x, 10 for first, minus negative 7.49 squared times its probability, 0.417, plus negative 20 minus negative 7.49 squared times its probability equals, and we get 14.712. Okay. And the reason I put minus and negative here is because really what you're going to do is add those when you're typing this into a calculator or whatever you're using to calculate the mean and standard deviation. So now we have a new question. If you play 10 games, so n equals 10, you can say that right away. And you have to realize this is our population mean and standard deviation. So now we got to calculate the mean and standard deviation for our sample of 10 games. So we know mu, of course, is the same, is still negative 7.49. And our standard deviation, or standard error, is the population, 14.712, divided by the square root of 10, which is 4.652. So now our question is, what is the probability you will make less than $15? So these are actual dollar values. So we do this the same way we did before. We calculate the probability, P, of X being less than 15, which is equal to P of Z being less than, well, we have to calculate Z. So Z equals 15 minus the mean, which is negative 7.49. So we're going to add that. Divided by 4.652 equals 4.83. All right, so the answer to this one is 0.9999 No. 99. So nearly 100% chance you're going to make less than $15 in this game. So obviously it's a very unfair game. And might as well call that 100%. So that's it for today. Have a good one.